All right, in this installment of Intro to Science, we will be talking about doing math with units. Okay, so when we do math with units, it's a little bit different than doing math in math class because we have to really make sure we're being careful and worrying about what those units are doing while we're going on and performing calculations. Okay, so first of all, a little bit about units of measurement. Scientists tend to use the international system of units, so that way when I write a paper and somebody in Germany reads the paper, they understand the units. And the United States is one of the few countries that still uses the English system. Okay, so like the inches and feet and all that other stuff. So I know you've heard about these before, and we just need to get familiar with like knowing how long these things are. Okay, so length is in a meter, mass is in a kilogram, time is in seconds, and temperature is in Kelvin. So you should get to know like what some familiar things are in these so that you have something to compare them to. So like a really tall person is about 2 meters. A really, kind of your average person is going to be around 75 kilograms or less, or somewhere, kind of give or take 20 kilograms. 75 is maybe a nice middle. Okay. Seconds, I think we're all pretty familiar with seconds. Kelvin, room temperature is 298 Kelvin. Okay. And the difference between Kelvin scales and other scales is Kelvin scales has a 0 that actually means something. 0 degrees Celsius is not the coldest temperature. 0 degrees Fahrenheit is not the coldest temperature. 0 Kelvin is the coldest temperature possible. Okay. In the metric system, we use prefixes. And so some prefixes that you should be familiar with, and there are plenty others, okay, will be actually on the next slide. But just to get you thinking about why does the metric system use prefixes, okay. Now, we probably know how many inches are in a foot. Okay, so you probably know that's 12. Do you know how many feet are in a mile? Maybe you do. That's 5,280. Okay, that's a fairly familiar one. Do you know how many pints are in a gallon? Okay, I think it's 16. Not positive. I wouldn't bet my life on it. Okay. Do you know how many ounces are in a ton? Could you do that math? Could you think, okay, well, I know it's 2,000 pounds a ton, and I know it's 16 ounces in a pound, so 16 times 2,000 is 32,000 ounces in a ton. Okay, there's all these different numbers you have to measure. Do you know how many rods are in a furlong? Okay, it's like, what's a rod? What's a furlong? Well, they are in the English system. Maybe they don't get used very much. Okay. If I'm in metric, all I have to know is what the prefixes are, and I can convert anything, and I can do it really quickly because they're factors of 10. So when you convert in the English system, maybe you have to multiply by 5,280. Maybe you have to divide by it. Maybe you have to multiply by 3. Maybe you have to divide by 3. Maybe you have to multiply by 16. Maybe you got to divide by 16. None of those are easy to, well, multiplying and dividing by 3 can be easy to do. But none of them are as easy as multiplying and dividing by 10, and that's what we get to do in the metric system, which makes it way easier. Okay, we just need to get familiar with the prefixes. So, if you start with a meter and you have a kilometer, the amount you multiply a meter by to get there is the same as if you go from a gram to a kilogram. Okay, so if I have something like a meter and I want to know how big is a kilometer, it's 1,000 times bigger. If I have a gram and I want to know how big is a kilogram, it's 1,000 times bigger. Okay? If I have a liter and I want to know how big a kiloliter is, it's 1,000 times bigger. Same thing goes with the other prefixes. The other ones that are going to be common that you'll hear are the centa, which is 1/100th. So a centimeter is 1/100th of a meter. A millimeter is 1/1000th of a meter. A milligram is also 1/1000th of a gram. A millisecond is 1/1000th of a second. Okay, so they're all the same, and they're all easy to do because it's just multiplying and dividing by powers of 10, which ends up just meaning you move the decimal some. Okay. Now, how do we know which way to move the decimal? How do we know, are we multiplying or dividing? Okay, and over the years you've probably been shown a lot of different ways to multiply and divide. I'm going to try to hopefully standardize this. Okay, and you might not like it at first, but if you get good at it, I promise you it will never lead you wrong once you know how to do it. And it applies to every type of conversion. And it's called the goalpost method or dimensional analysis. And so it gives you this general form. You take your blank of A, you multiply by your conversion B per conversion A, and you get a conversion B. Or you get a number in B units. Now that's like, wow, what does that mean? Well, I'm going to show you some examples, and then that way you'll hopefully know what it means. One important fact is that this number right here, that equals 1. Because you can always take a number and multiply by 1 and get the same number back. So when you multiply by this conversion, this thing in parentheses, all you're doing is multiplying by 1. So you're changing the units without changing the value. Okay? So we're looking at, well, how is this multiplying by 1? For example, 100 centimeters equals 1 meter. Okay? So if you think about it, well, 1 meter divided by 1 meter equals 1. Okay? Well, if I replace one of those 1 meters with 100 centimeters, because 100 centimeters equals 1 meter, remember? So I can say 1 meter over 100 centimeters equals 1. And even though in your mind you're like, well, 1 divided by 100 isn't 1, 1 meter divided into a 100 centimeter piece, that is 1. Okay? So when I'm multiplying this thing, I'm multiplying by 1 and I'm not changing the value, I'm only changing the units. Okay? So, for example, if I look at this and I say, well, I have a board that is 143 centimeters. How many meters is it? So remember I had that blank A times the conversion of B over the conversion of A equals blank B. So my A is what I'm starting with, so that's centimeters. My B is what I'm ending with, so that's meters. So I'm starting with 143 centimeters, okay? And then what I have is I'm looking at, well, okay, I want centimeters to go away, so I put it on the bottom. I want meters to come in, so I put it on the top. And so 1 meter, again, is the same thing as 100 centimeters. So now I'm taking 143 centimeters, multiplying by 1 meter on the top, dividing by 100 centimeters on the bottom. Centimeters, since it's on the top and bottom, because remember I can think of this as being over 1. So centimeters, since it's on the top and bottom, goes away. So I'm left in units of meters, just like is what I want. Okay? So I'm taking 143, multiplying by 1, dividing by 100, and I'll get 1.43 meters. Now, maybe somebody along the way taught you a trick about, like, you line up all the prefixes in order and you move the decimal one way or another, and you could get the same answer. And that's great when that's all you're doing is going from centimeters to meters. But as you go on, you're going to want to do more conversions rather than just going from like 1 unit of length to another unit of length. And it's better to learn to do this with the familiar before you're forced to do it with the unfamiliar. Okay? So there's some more examples here that I want you to try. Okay? And I'll help you set up some of them. So if we're going from grams to kilograms, we're going to start out with our 45 grams. We're going to go, okay, gram, kilogram. Well, I remember 1 kilogram is 1,000 grams because that's what that kilo prefix means, is that it's 1,000 times bigger. Okay, so I could write underneath here like 1,000 grams equals 1 kilogram. And that's where I'm getting my conversion from because this fact just plugs right into there. And then grams will cancel so I can get my answer. So try that out. If you have 1.5 millimeters to centimeters, okay, well, a millimeter is 1,000th of a meter, okay? So 1,000 millimeters equals 1 meter. And a centimeter is 100th of a meter. So there's 100 centimeters in a meter. that means 1,000 millimeters equals 100 centimeters. Okay, that means if you divide out the 100, okay, so you can divide both sides by 100. 10 millimeters equals 1 centimeter. Now maybe you could get that, okay, quicker than what I did. Maybe you already knew that. I'm just showing you where it comes from and how to do it using just the very basic facts. Okay, so I'm going to start off with 1.5 millimeters. Put my 1 centimeter for every 10 millimeters and see what I get. Okay, and again, I want you to do these. Try to do this one completely on your own. Ask me tomorrow if you did it right. Whoops, sorry, this is goofed up. You can't do that one. 134 milliliters to liters. Okay, that'll be a way of seeing where you're paying attention to the notes. Okay, when you're doing math and science, you need to make sure you consider what the units are, what's happening before you do operations on them. Okay, kind of like, you know, when the surgeon, you should consider, like, are you operating on somebody's spleen or somebody's leg before you get started? So, for example, when you add and subtract, you need to have the same units. You cannot take one apple and 3 bananas and end up with 4 apple bananas. Okay, apples and bananas are 2 different things that cannot be added. Now, if I said I have 1 piece of fruit and 3 pieces of fruit, I have a total of 4 pieces of fruit. If you convert them to similar units, if that can be done, you can add. But you have to do those conversions first, okay? When you multiply and divide, whatever you do to the number, you do to the units. So if, let's say, you're finding area of something, and I'm going to go take 10 meters is one side of my square by 20 meters. When I'm doing this calculation, I do just like I would my calculator or by my hand or pencil or head or whatever. I take 10 times 20, well, that's 200. And I don't just say 10 meters times 20 meters is 200. And 10 meters times 20 meters is not 200 meters. Whatever I do to the numbers, I got to do the units. So I took 10 times 20. I got to take meters times meters. Well, a meter times a meter is meters squared. So I have units now of meters squared. Okay? Now let's say if it was 5 centimeters long by 0.1 meters, okay, I could multiply those out and I could get, well, it's 0.5 meter and then multiply the units meter centimeters. That's kind of a weird wonky unit, and so it would make more sense if you put them into a common unit first before you multiplied. Okay, and we'll work some examples of that in class. I kind of got to get moving on. I'm getting, you know, ending up towards the end of the video here. Okay. As we're going now, a special note about division, and I don't know how I got off here, but very few people actually understand what division means. If you're trying to show me what's 12 divided by 3, so I might say, okay, well, I have 12 balls, divide them by 3. I'm going to get a couple of different answers, okay? I don't want to draw them all out real quick, so just Control D, boom. It didn't work. So I've got 12, okay? So on your notes, show me what 12 divided by 3 would look like visually. Okay, we'll talk about that. Because as we see here, do I mean when I say 12 divided by 3, do I mean take 12 balls and divide them by 3 balls, which would just give me an answer 4? Do I mean 12 balls divided by 3 people, which would give me 4 balls per person? Or do I mean take 12 balls and divide it by 3 balls per person, which means I can divide it up to 4 people? Okay, so depending on what units you put under division, your division could mean some different things. Okay, so that's, you know, something to consider with division. All right, so I think that's all the time I have for this one. Maybe we'll be looking at another one later on about density.